Our rest method will send the rest event to the finite state machine, and that is going to cause a change to the idle state. The moving oh, and when we leave the moving right state, we are going to stop the particles. Um, the moving left methods are the same as the right methods, but things change according to the input to the left, and the, the positions checks are different because we are moving to the other side, but it's basically the same. And we also stop the particles when we are leaving that state. If we jump, we are going to call this method, and we are going to set a vertical speed. That is our jump speed that we also set via our inspector in here, jump speed of 10. And we set the material to jumping material. Each frame, when we are in jumping state, we are going to use this method that handles aerial vertical movement. And what this is going to do, it is going to here we get the delta time, and here we have a speed delta. This is how our speed is going to change each frame because of the gravity, that is an acceleration going down. So we multiply that for our delta time, and we have our speed delta, and then we subtract this value for our vertical from our vertical speed, and then we create our vertical move delta using that new vertical speed. We once again have to use the delta time to get our delta, and then we translate our character using that vertical move delta. So basically we are controlling how the speed and the distance and the position is changing with gravity. Here we set here we ask if our position has go below our ground position, that is 0, and if we have go beyond, then we set the position, our vertical position, to be 0 once again. So our character isn't stuck in the ground. Isn't stuck. Well, okay. Also, when we are jumping, we have this rotation logic, so our character spins. We create a rotation delta using a rotation rod speed that is also set via the inspector here. And we rotate our character using that delta in the y-axis. And we check if our vertical speed goes beyond 0, and if that's true, then we call the fall method that will send the fall event to our finite state machine, and we are going to start falling. And here, when we are falling, we are going to call this method to set the falling material, and while we are updating our falling state each frame, we are going to use the same method that we use in jumping update, because it's the same thing. We are going to keep changing our speed using gravity, and we are going to keep changing our position using our new vertical speed. And here, when we are falling, we check if our position goes beyond our ground position, that is 0, and if we do, then we go to rest. We doesn't have to worry if our position go to negative, because when we start the rest state, we set our position, our vertical position, to 0 in y again. This is useful we start moving left and right, our character is moving up and down, but when we stop, we set our vertical position to 0 again. So instead of doing this at the end of the moving states or at the end of the falling state, we can only put that here in the idle state, and it's better. So now I'm going to explain other part of the codes that are here for you to understand the example. For example, here in our start method in our mono behavior, we need to stop the particles that are for default playing, and we call the initialize finite state machine method, so we can set everything up before it starts. Well, I think I have explained all the methods that we're using here. I think I need to explain something else. So we have some things that we didn't use before. Here we have this to ask which is our current state. We're going to get an object that we can then cast into the enum that is our state. And the thing is that you can use anything as a key for states and events, but I recommend that you use an enum for that. And you can also ask which was the previous state key. So in some cases you're going to need to determine or to know what was the previous state, and depending on that you are going to use a different logic, so you can do that too. And as you can see, by using this you can easily add new events and states to your state machine, and you have a structured and organized way to put your logic. And if you happen to need another state machine to control another aspect of your character, for example, I don't know, if you are grabbing a power up and you want to handle the states for that separately from this, you can have two state machines, and each one of them control different things of the character. If you have things that happen in various states, as it happened here with the aerial movement method, then you can call that method in both of the states, and still it is more controlled that way. And if you have some logic that happens every state, then you can put that code outside of the finite state machine methods by calling a method in the update or directly putting that logic in here.